Good morning and welcome to Twyford Bathrooms. My name's Dave Broadhurst and I'll be your tour guide for today. There are just a few points that I'd like to make before we set out on the tour. First of all, welcome. Secondly, please don't take cameras round as we do not allow photography. We don't allow smoking. We'd like you to turn your mobile phones off. Now those are the bad points. In the good points, please feel free to ask as many questions as you like. Talk to the people who work on the factory, they're very friendly. Above all, keep your eyes and ears open as there are hazards within the factory such as forklifts and trucks. Now the factory itself has been here since 1956 and the company was founded by Thomas Twyford in 1849. The site that we're on currently is 70 acres, which is a very large site. The tour will take anywhere up to 2.5 hours. So if you would like to use the toilet, I suggest you do it now, as there are thousands on site, but none of them are fit for use. And above all, enjoy yourselves. Now, as the factory can be fairly noisy, we have to use headsets so that you can hear me talking. These headsets are very, very simple to use. You only need to worry about one knob. To turn the receiver on, or to adjust the volume, just rotate the knob in a clockwise fashion. If I'm talking too loud, you can turn it anti-clockwise to turn me down. If I'm too quiet, you can turn it clockwise to turn me up. Please, whatever you do, don't turn me off. Now, as regards the earpiece, it can work with both ears. If you use it this way, it fits over the left ear. And if you want to use it over the right ear, all you need to do is pivot the earpiece and then place it over your right ear. Now, as we go through the factory, if the fire alarm should sound, please don't run around like headless chickens. Just follow me to the nearest fire evacuation point.
Hi, we're in the reception at Twyford Bathrooms, and this is where we display some of our old products, the products from our archive. And this is our favourite piece. This is the Unitas closet, and it was invented by Thomas William Twyford in 1883. This actual piece dates back to 1885, and it's a very, very important piece in the history of sanitary ware. It's the first ever one-piece, all ceramic, pedestal washout closet. So really it's the first toilet. When people talk about Thomas Crapper being the inventor of the toilet, he's completely wrong. It was Thomas William Twyford who invented it, and this is it. And we're very proud of it. On the outside you can see it's got these relief decorations of oak leaves, and on the inside there's decoration of dahlia pattern in blue. We called it the Unitas because it was the first unit piece. It was the first toilet that didn't require any other supporting timbers or any other joints. It was a one-piece closet, a Unitas. And he exported these Unitas all over the world, into Australia, America, and into Russia. And it was a very, very popular product in Russia, so much so that the Russian language has now absorbed the name Unitas. So if you want to go to the toilet in Russia, you actually go to the Unitas. It's Twyford's Unitas, which is the word for it over there. So it's a very important piece to us, and we're very pleased that we've got it on display amongst all the rest of the stuff. Important piece for us. This is Twyford's own bath. It's a fire clay bath, pottery, made in 1896. And Twyford obviously made a good job of this one because he installed it in his own house over in Whitmore, which is about 8 miles away. And he had it there until he died in 1921. And it remained unused then right through the 20th century. It was only towards the end of the 20th century when the current owners, the Kavanagh Mannerings, offered it back to us, and we went along there and inspected it. Yes, we did want it, and we started the job of getting it back to the factory. What a job that was. It takes 7 men to lift this thing. It weighs about half a ton. It's a huge bath. It's lovely. It's 6 foot long, over 6 foot long. It's got this wooden pad on the side, these wonderful marble glazes, and inside the bath there's even a slip resist pattern. But it was installed 3 stories up, so it was in Thomas Twyford's living quarters, but right at the top of the house. So we had to get a crane and forklifts and all sorts of tackle to get it out of the place and then brought back here and installed at the factory. Very proud of it, great talking point. I could go on for hours, but I won't. Have a look at it in a bit more detail. Well, here we are with some more archive materials, and these are products which we've collected over the years and put them on show for visitors. Loads of people come to the factory and they love seeing what we've got. These are duplicate pieces actually, because we've got the equivalent amount over at the Gladstone Pottery Museum, and these are all Twyford or Royal Doulton pieces. Got some fantastic products. There's another Unitas over there. I've mentioned Unitas earlier, and this product down here, if you can just pan across with me, this one in the right hand corner is called a Twycliffe, and this is the first ever siphonic closet, and it was such a complicated toilet that it was actually made in 13 different pieces, and it was stuck together, just as we'll see later on the factory, using congealed clay to stick the different parts together. 13 different pieces. Then it was fired, and then it was decorated. You can see the brown and blue decoration, and then it was fired again. But the key thing is that it was a siphonic closet, so it sucked the contents of the bowl out down to the drain rather than flushing them out with the force of water. Yeah, we've got some terrific pieces, and we're very proud to show them all off to our visitors. I'm standing in front of this huge brass bell, solid brass, beautiful sounding bell, and it was produced by Thomas William Twyford. There's his inscription, in 1887, and this was the date that Twyford built his factory in Cliff Vale. The Twyford factory was a model factory, and it was regarded by experts and the local factory inspector as being one of the best in the area, because every worker in the factory had his own opening window, and it was regarded as being the bee's knees in factories, and people came from all around to see how it was built. But this was in the cupola on the top of the building, and Mr. Twyford himself, Thomas William, used to ring the bell to bring his workers into work at 8 o'clock in the morning. Very proud of that. And here he is. We'll have a look at his portrait. Thomas William Twyford, the son of the founder. He's there with his Staffordshire knot, and he was an amazing chap. He was a marketeer, he was an inventor, as we've seen. He invented the first one-piece closet, and he made a lot of money out of it. Now, this is a masterpiece in wash basins. Believe it or not, this was Twyford's Athena wash basin, made out of earthenware, marbled so that it looks like marble. It's this transfer printed decoration, and then mounted on a cast iron stand, and the cast iron was painted to look like wood. So we've got pottery and cast iron made to look like marble and wood. Now, how daft is that? But that's Victorians for you. Lovely piece of work, and we've recently got it back and put it on display for visitors. It's another talking point.
We're now in the product development area. This is the start of the manufacturing process. Now, obviously it's not the real start. The real start is by going out, doing market research and finding out what people want to buy. We then have to decide, can we make it? It may sound a bit of a stupid thing to say, but there are products that we would struggle to make given the nature of the materials that we use. The basic process can follow two routes. We usually start off with a drawing, and from that, traditionally, we would make a plaster model. We now have the option of producing a piece via CAD, or computer-aided design, which we can then take onto the 5-axis machine and manufacture a model straight away. The old process takes a lot longer. It takes weeks rather than days. The traditional method coexists with the new method, although the new method is becoming more and more popular due to the fact that it reduces lead times. From the drawing, we have to produce a plaster model. Now, of the 3 pedestals that you can see on my left, the first one is the plaster model. It's obviously a lot larger than the other 2 pieces. The plaster model is the master from which everything will be produced. Now, it's not carved lovingly out of one piece of plaster. It's built from several sections dependent on the piece. Now, this can take 2 to 3 weeks to get to this stage. The next stage is to produce what is called a block mould. Now, this mould is the master mould from which all of the moulds will be produced. I said that a simple mould would comprise 2 pieces, and I did say that in this area we do things on a larger and more complex scale. For example, around me you have several sections of a block mould that will form a closet. There are at least 4 pieces. You will notice that the mould is coloured a delightful shade of salmon pink. There is a reason for this. This immediately identifies it as a block mould, so anybody on the shop floor knows that that is a valuable piece. Weeks of work have gone into this. So why colour it salmon pink? Because in years gone by, people have been known to throw block moulds away, which is a big on-cost to the company and a sheer waste of effort. Route, as I explained earlier, towards producing a piece is the CAD and CNC machine route. Now, this is considerably faster than the traditional method. For example, the machine behind me is now cutting half of a basin block mould. Now, this will take about 2 days, as opposed to around 5 weeks. Now, the ultimate aim with the CAD and CNC is to actually cut out the stage of making a model and go direct from computer-aided design to producing a block mould, which will save weeks in process time and again weeks in lead time, thereby justifying the £1 million investment that it took to bring this machine to the company. Blocking and casing department. Now, going back to the original idea of having a 2-piece mould for a football, that's great if you just want to make one mould. But what if you want to make thousands of moulds? Then you have to have something that will enable you to produce that mould hundreds and hundreds and hundreds of times. Now, this is achieved by the following process. Behind me we have 2 halves of a basin mould, of a block basin mould. The insides of these moulds are coated with a gel resin. Now, it's not tremendously thick, it's between 1 and 2 millimetres, but this gives us a perfect representation of the face of the mould. Once the resin has dried, it is then backed with a backing of sand and fiberglass, which gives the case its structural rigidity. The reason we use this process is that resin cases will last for the life of the piece, up to 15 to 20 years. In the old-fashioned way, where we made cases from plastic, they would last for 9 months, and we would have to reproduce the case again and again and again. We do it now. You haven't got one mixed, have you? No. Just wait. We've got packs of time. coating has dried, it's then finished off by the case makers to a really high quality finish. Now this is extremely important because obviously the finish on the case determines the finish on the mould, which determines the finish on the piece. Now the finish on this is achieved not with power tools, but by good old-fashioned elbow grease and finer and finer and finer grades of wet and dry paper. So from a simple two-piece mould, you can see that a lot of effort goes into making sure that that piece finishes up as a good piece. We're now outside the slip house, which is where we produce the raw material that makes the piece. Now slip is dug out of the ground basically, and as you can see on the two photographs behind me, the first one demonstrates the production of china clay. It's literally blasted out of the ground using a water cannon and then filtered and filtered and filtered to give us china clay. The bottom picture shows you ball clay production. This is basically dug out of the ground in huge chunks and refined. The other ingredients that go to make up slip are sand, which actually comes from Chalford, which is near to Jodrell Bank, and nepheline cyanide, which is used as a flux. Now that comes from Norway and Canada. Now the three are mixed together to form a very thick liquid paste. In terms of the volumes of slip produced, you can see on the board behind me that we produce 87,500 gallons a week, roughly 450,000 litres. And if you drank 8 pints of beer every night, that would last you 240 years. To put it another way, it would fill your bath at home every day for over a year if we produced just 1 day's slip. Just had a lightning tour of the slip house, which showed you storage arcs, which hold up to about 8,000 gallons each. Once the slip's been held in those arcs for a day, it passes over the sieves, and you saw one of the meshes. As you can see, the meshes are very fine, and that is critical to the process. Once the slip has been sieved, it passes over an electromagnet into another storage arc where it is held for a further 24 hours before going into production. Making department. Now what you saw in the modelling area and blocking and casing is important in this area, so please try to remember. Mould making process, very simple. You take plaster and water, mix them together, pour them into a case, allow them to set, and then remove them from the case. That is, of course, assuming that you use the right amount of plaster and the right amount of water every time you mix. Otherwise, you can have disastrous results. The plaster takes around 20 minutes to set. And once it's set, we can then remove it from the case, finish all the edges so that it's safe to be handled by the caster, prepare the case for its next fill, and then move on to the next stage. just seen Phil actually preparing the case for the next fill with plaster. What he's actually doing is spraying a solution of soap and water, which helps to release the plaster from the case. This is the second type of mould that we have in use on the factory. It's actually a pressure casting mould, which is porous resin which allows the water to pass through the mould. As you can see, it's a simple two-piece mould. Currently we can only use a two-piece mould. That is not to say that in the future we will not get into four-piece moulds. Now this is capable of producing a piece every 7 minutes. So why don't we produce everything this way? One, because you need massive investment. And two, as I've already mentioned, we can only use a two-piece mould. This mould will last for in excess of 25,000 casts at a cost of around £11,000 per mould. The finish on the piece is no better and no worse than any other piece we produce in the traditional fashion. We're now in one of MRF's casting areas. There are 4 types of casting within the factory: bench, beam, battery and pressure cast. Of these 4, bench cast is the oldest, the most traditional method. The moulds are cast only once a day. The mould's filled with slip, which is left in the mould for between 60 and 70 minutes, depending on which day of the week it is, as the cast is never the same twice. After it's been in the mould for around 60 to 70 minutes, it's then demoulded and the piece is finished. Now, bench casting can be affected by many factors, such as the temperature and the weather. If it's a wet day, the piece takes longer to dry. If it's a warm day, the piece dries faster. Now, the caster has to use his years of experience to judge when to handle the piece, when to fettle the piece, when to lift the piece, all according to the type of day he's having. into the second form of casting on the factory, which is battery casting. A battery is basically 50 to 54 moulds strung together in a row, all filled and emptied by one man twice a day. It's no different in that respect than bench casting. It still has to be finished by hand, all the holes have to be punched. It's the same casting process. It is just more cost effective. Type of casting that was mentioned was beam casting. The beam casting was originally brought in from Dalton. It's called beam casting because the moulds are strung together across a beam, the big blue girder that you can see behind me. There are 24 moulds on each beam, and each beam is cast 3 times a day. The main difference between beam casting and traditional bench casting of closets is the fact that the piece is filled and emptied from the bottom. Once the ware's been cast and placed onto trucks, it must be dried before the next part of the process. Drying within the factory is in various stages. We have 12-hour drying, 24-hour drying, 48-hour drying and 72-hour drying, depending upon the complexity of the piece. The next stage in the process, once the ware has been dried, is inspection. This involves the overlooking of the piece to find any faults that may have occurred during casting. As you'll see, there are very simple tools in use, such as a bucket, a sponge, a scourer and a compressed air line. Once the piece has left the inspector, it is ready for spraying. After inspection, the ware passes to spraying. Spraying involves the coating of the piece twice with glaze. The aim is to get a thickness of between 0.6 and 0.8 of a millimetre, and this is all within the sprayer's control. product that we produce and whether it has a badge or not. When the ware has been sprayed and badged, it's placed onto kiln cars. It's essential that they're placed in a uniform fashion, as this can affect the performance of the kiln. On site we have 6 gas kilns. There are at least 2 varieties. The one behind me, kiln 12, is a skate kiln, which was a £4 million investment. This kiln is lined with ceramic fibre. It is an open flame kiln, and it takes a truck 12 hours to go from the entrance end to the exit end. The kiln on my right, which you'll see later in shot, is a muffle kiln. This kiln will fire on a 20-minute push. Another important difference between the 2 kilns is that the ceramic fibre line kiln can be closed down in a matter of days. With the old traditional brick kilns, it takes a matter of weeks. This is why for most companies, brick kilns are left running throughout the year. Once the piece has been fired, we come to probably one of the most difficult jobs on the factory, cloth selection. These people have to make the final decision on whether this piece reaches a customer. And believe me, when you're sorting 700 pieces a day, it's all too easy to make a mistake.
welcome to the NDC, the National Distribution Centre. We're in the offices department, and this is the commercial bathrooms. If you just move over here, I'd like to introduce you to our estimating department. This is where it all starts, when the architect has prepared the drawings for a project and requires them to be priced. We have an excellent team here that do pricing for them and is then sent back to them. When the order is then converted, we'll just move over here. This is where we do the pre-plumbed units. From the estimating department of pricing, we've got the orders. What we'll do is prepare the full set of drawings for the architect, and these will then be approved by the contractor on site and then shipped directly to site and fitted. If we now move on, I'm going to actually move into the main distribution centre where all the products are stored.
Now in Goods In. This area accepts all purchased product. Now, as you can hear and no doubt see, there are plenty of forklifts around, so please remember what was said in reception regarding keeping your eyes and ears open. In this area we receive metal baths from Spain, acrylic baths from Hull, and product from Fireclay and other areas. Baths are pre-inspected prior to being accepted into the NDC, and other factory products, fittings, etc. will still come through this area. We receive a number of lorry loads per day. Right, I am now a finished product and have arrived at finished goods receipt. Footage you've just seen, we've actually noticed that bubble wrap has been placed around each item, along with protection for the feet of closets and for the outlets of basins. Once the packaging protection has been put on, the piece passes down the conveyor to a stage which is called verifying. Now, the barcode that you saw on the previous footage is actually scanned to ensure that if it says it's a Solar 510 with 2 taps in white, that is actually what the piece is. If this is the case, it passes through into shrink wrapping, moves down the conveyor, and is then given another barcode which is specific to NDC. The pieces are then palletised by product, by pattern and by colour before going on to the next stage of the process. We're now actually in the NDC, which was built in 1994 as part of the company's commitment to invest at a cost of 10.5 million. The NDC itself is 33,000 square metres of floor space, or the equivalent of 5 football pitches. It's 14.5 metres to the eaves and has the capacity to hold 450,000 pieces of VC, plus baths, plus all the ancillaries. Now, what you can see over my shoulder is that there are lots and lots of racks. Each of these racks has a pick location on a label on the girder above each location. For example, we have AA14A, which is a location. Now when a pallet of wear is brought in from FGR, the computerised system tells the driver where to put the pallet because all these locations are computer controlled. Once the forklift driver puts the pallet in that location, he scans the barcode above the location which tells the computer that that pallet of wear has now filled the empty pick location. We are still in NDC, we're now in the merchandising area. Now this is a growing part of our business. It's based around packaging complete bathroom suites into one box. So that you have the bath, the toilet, the cistern, the pedestal, the basin, all the fittings required, all in one box. Now obviously this makes life a lot easier if you're planning loads, because they're all uniform sizes. It makes storage a lot easier. It also protects the product. Now the packs may vary dependent on the needs of the customers. As I say, some may have a full bathroom, some may just be 4 pieces of sanitary ware. The most important pack that we make, and have made for the past few years, is the Dock M pack, which was basically the first disabled toilet facility in a box. This has led the market for a few years now, and our competitors are still trying to catch up. But as I said, it is a growing part of our business. Another important change in the way we process product in NDC is actually the area that's behind me now. This is called the lake configuration area. Now, given the fact that the company has a wide variety of cisterns, each of which has 3 different variants according to the cover, it became impractical to try to store each cistern and cover variant within the NDC. So what we now have is the cisterns are stored separately from the covers, and then the variants are configured in this area by adding the lid and the fittings. In addition to this, we now have the ability to use internal overflows on most of our cisterns. And again, all of our cisterns are now 6-litre flush compliant, which is important due to the European regulations that were introduced last year. We were the first company within the bathroom industry in Britain to get the 6-litre flush on all our cisterns. The last part of the NDC process is obviously the distribution of the ware. We currently have 2 different methods. One, if it's for export, we use containers. Now the containers are packed in 2 methods. We either use pallets or we use coffee bean sacks to protect the ware during its journey. The other method of transport is by 40-foot curtain siders, and again, these are predominantly done with pallets. It's important that the load is planned and picked correctly.
This is a container going to Canada.
Even though we're a large company, we don't just cater for the big boys. We also have certain orders that won't require a 40-foot trailer. or a container. They may only require a small van. Items that are in this category are packaged and distributed from this area. Also, single items which people have requested for collection are also taken from this area. There are forklifts in action around this area, so please remember what was... Sorry.
Okay.
Right. Is that in shot?
Not yet. It will be. Oh, hang on, hang on.
Yes. Falcon.
Okay. Fire.
Right. I am now a finished product and have arrived at finished goods receipt. This will test your sound level. Oh.
This sometimes happens while you're on tour.
What? Schnoz? No, whistling into the mic's the one that happens. That's all. Right, you ready, Woolly Socks?
And action.
When they supermarket CNC.
Computer numeric control.
Oh. Computer numerically controlled. It's a bit like slip, well adjusted, numerically kept. That's Steve Bostock, isn't it? Right, are you ready, Mr. Woollycraft?
Are there any blonde girls in this video? And has he got any Durex on him? Check him first.
No, he's got a duck scan.
I know about Durex, but I know it was a dickhead one side of the camera. I'm not saying which side. It's just a matter of knowing what you're talking about and being confident in what you're saying is right. And if you're confident, then you're not in the middle and you're saying right, slip house, the place where slip is produced. So what's slip? Everybody says it's clay and water. Well, they're partially right, but not quite. It's extremely... No, cut it, Dad, 2.
This is take 2 in the slip house.
Right, we're now outside the slip house, the place where we produce slip, which is the basic raw material that we use to produce the pieces that the company may hold.
Slip house.
Right.
Take 3.
We're now outside the slip house, which is...
Okay.
You've just had a flying tour around the slip house, where you've seen the storage arcs, which hold up to 8,000 gallons each.
Stop.
You've just had a lightning tour of the slip house, which showed you storage arcs, which hold up to about 8,000 gallons each. MRF bench casting. Bench casting is one of the 4 forms of casting that take part in... Do that again. Take part, take place. We're now in MRF casting. There are 4 types of casting that take place in the factory. Bench, battery, beam and pressure cast. We're currently in MRF bench cast area. Bench casting is the most traditional form of casting, which is not quite as productive as mechanised casting. I'm going to do this. What you've just witnessed is part of bench casting. On the company we have 4 different types of casting. Bench, which I've already mentioned, beam, battery and pressure cast. Bench casting is the most traditional form of casting. Each mould is cast only once a day. The mould's filled with slip, allowed... Oh, bloody hell! The third type of casting that I mentioned was battery. Oh, was it buggery battery? It was beam, you stupid boy! Do that again. Shall we try that again,
It's mobile.
So where do you want me, Terry?
I don't see you very often, but when you do...
This is a tour
Hey,
guide.
this is a still a tour guide.
Tour guide,
This
yeah.
is a tour guide.
Before we set out on the tour, since there are quite noisy parts of the factory, we use electrical equipment, we use headsets. Now the headsets and the controls are extremely simple. All you need to worry about... Noisy.